with. All right. Any other questions?
For homework, cylinders and the quadriceps surfaces, for number 3, I wasn't sure how to graph it.
Well, I'm getting ready to give you the
Oh,
answers for those.
oh, okay.
Okay. All right. So let's take a look at those. All right. So the first problem that we had was that we had that x squared plus y squared equals 4. So if we think about this particular problem here, we basically are going to have a circle in the xy plane. So let's stand these out. Okay, so we have a circle that's centered at 0, 0. The radius is 2. So we're going to go 2 on y on both sides, 2 on x in both directions. So these are going to create the outsides of the outer of the circle. So here's your circle. Now, as far as this is concerned, okay, it's void of z. So z can take on any value, all right? So it will be parallel planes. Okay, and basically, this will be your drawing for x squared plus y squared equals 4. Any questions there? Okay, let's look at the next one. So the next problem we had was 9x squared plus y squared plus z squared is equal to 9. So essentially what I'm going to do is just kind of alternate what variable I'm going to let be 0. So the first time I'm going to let I'm going to let z be 0 first, not x. So I'm going to let z be 0. If z is 0, it's going to create the equation of this. Then next, I'm going to let y be 0. And if I do, it's going to create this equation. And then finally, I'm going to let x be 0. And it's going to create the equation of this. Okay, and so what I'm going to do is to graph each one of those equations to create my graph. Okay, so first time, so the first time I'm going to be in the xy plane. Okay, so if I look at that, okay, basically I'm going to be graphing in an ellipse. So on x, I'm going to go 1 unit in positive, 1 unit negative. In y, I'm going to go 3 units positive, 3 units negative. Okay, and that generates my ellipse in the xy plane. Then next, I'm going to move to when y is 0. So this is going to be an ellipse in the xz plane. Okay, so x is going to be 1. Okay, on z, and I've already got the ones marked on x. So on z, we're going to go 3. So 3 up and 3 down. Okay, so And there's my ellipse in the XZ plane. Okay. And then finally, I'm going to, and sorry, let me switch colors. The colors do match. There we go. All right, so finally, I'm going to do a graph in the YZ plane. Well, if I look at the graph in the YZ plane, it's going to be a circle with a radius of 3. Okay, so basically, starting here and make a circle all the way around this, and this will represent my graph. Any questions? Okay. My next problem was that z is equal to x squared plus 4y squared. Okay. All right. So if I take a look at this, okay. So if I made z 0, basically what I'm going to end up with is the 0.000, because that's the only way it would be true. Now, if I take a look at this, since it's x squared and y squared, there's no way that z can ever be negative. So it's never going to go below. It's not going to go into the negative sense. So I don't have to worry about anything in the negative axis. Okay. So now, if I take a look at this, okay, here's x, here's y, here's z. If I take a look at this, okay, if I say I let x be 0, I'm going to have that z is equal to 4y squared. So basically what I'm going to do is I'm going to graph a parabola in the zy plane. Okay, so if I graph a parabola in the zy plane, let's say I go 1 unit, excuse me, not 1 unit up, but 1 unit on both, in 1 on the y, 1 on negative 1 on y, so 1 and 1. So that means that z is going to be, let me mark this, 1, 2, 3, 4. So z is going to be 4 units up and 4 units up. So it's going to create not so much of a curve as what I'm doing here, but fix that. Now, please keep in mind that this is not crossing the x-axis at all. Okay, it's not intersecting with the x-axis at all. All right, then the other aspect is that if I let y be 0, I'm going to have 0, z is equal to x squared. Okay, so we're going to be along the x-axis this time. So we can go 1 positive, 1 negative. Now, it is going to be going up. So going up in the aspect and up in the aspect. Okay, and I'm trying to create, and by doing the different colors, you can kind of see that I've got these two parabolas going on. Okay, so essentially what's going to happen here is that once I get there, I can realize that I can create a circle connecting these. Okay, and it's not going to be so much of a circle, it's going to be more of an ellipse, because if I pick values of z that are nice, so I could pick the value, say 4. If I let z be 4, and then I have x squared plus 4y squared. or 1 is equal to x squared over 4 plus y squared over 1. So I've got this ellipse going on. And this, what I've got in red, is that ellipse that's going to happen. Okay, now I'm putting it on the end, but it would be basically down here. And let me put it in where it's at 4 units up. Okay, and then you just have those going up, going as z increases, you're going to have ellipses going up. Okay, any questions there? Okay, so for problem number 4, we have that x squared plus y squared is equal to z squared. Okay, so if we take a look at this, all right, so one of our points is going to be 0, 0. Okay, one of our points is going to be 0, 0. Well, 0, 0, 0. Let me say it correctly. Okay, now if I look at this, okay, since it's equal to z squared, that means we can increase or decrease z. So if I let z be 1, I'm going to end up with x squared plus y squared equals 1. So basically, I'm going to have a circle that is going to be in the it's going to be in the z equals 1 plane. Okay, so let's kind of represent that, and let me switch colors. So there's this one up, and then I'm going to have a circle that is going to be created 1 unit up high, up above. Now, the thing is that if z equals -1, I'm going to get the exact same thing. So it actually will also go down, and I can create a circle like so. Now, what's going to happen here, and my circles are kind of off, but essentially what's going to happen is that as z gets larger, I'm basically going to have a set of concentric circles, okay, that are going to be going along the z-axis. So I'm going to have a set of concentric circles going up, and then the same set going down, okay? And it would have been better if I put these in. So essentially what's going to happen is that as we go up, I'm going to have circles that are going to occur here. And in the same situation as I go down, I'm going to have circles going along here. Okay. Any questions? Okay. All right. Next, we have x squared plus y squared minus z squared is equal to 1. So if I take a look at this, if I start off with z equals 0, I'm going to end up with x squared plus y squared equals 1. Okay. So I'm going to have a circle in the xy plane with a radius of 1. So 1 unit, 1 unit, 1 unit. And let me fix this 1 unit here. 1 unit, 1 unit. So I have this circle. Okay. Now, the thing is that as z increases, what's going to happen to the radius of the circle? So as z increases, what's going to happen to the radius of the circles created?
Larger.
They're going to get larger. So essentially what we're going to have is we're going to have a situation basically on z that we're going to have circles that are going to get larger. Okay. And these do curve. So as we go, they're going to get larger as z gets larger. And same way as z gets smaller, they're going to get larger. So this is what your figure is going to look like. Now, please keep in mind that I'm not expecting 100% accuracy, but I am expecting something in the general ballpark, okay? So I'm not expecting you to be perfect on your graphs or anything like that by any means. But if I gave you this equation, but you drew it along the y-axis expanding, then that's not correct. That means you didn't understand how things were, how it should be oriented. Okay. Any questions? All right. Then the last problem that we have, which is this. We have y squared minus x squared equals z. Okay. So for this, if z equals 0, oops, if z equals 0, that means we're going to start at the center at 0, 0, 0. Now, if we change just slightly, so if we say that z is 1, okay, so if we do z is 1, basically what we're going to have is the equation that y squared minus x squared equals 1. So if we take a look at this, this is going to be the graph of a what? Not a circle. So if it's minus and squared, it's going to be a hyperbola. Okay. So with the hyperbola, what we're going to end up with is we're going to have hyperbola going on in the xy plane. Okay. So we can, I'm trying to think how I want this to look. Okay, so when I do this, and since z is 1, all right, so essentially what's going to I can do z as 1 or I could do z as 1 or z as -1. Let's look at z equals, let's look at it in terms of z equals -1. Okay, so if we do that, all it's going to do is switch the variables around. So essentially what we're going to have, and this is going to be kind of a sketch on my part, we're going to have we're going to have a piece of hyperbola here. Oops, that should not curve so sharply. So we're going to have a piece of hyperbola down here. And then we're also going to have another piece, and it's just going to be kind of behind. Okay. Now, also, something that happens is that we are going to have a couple of parabolas coming on in here. So we're going to have a parabola that is basically going to connect these hyperbolas, and it's going to end up connecting them at the ends also. And overshot this in a little bit. Okay. And then finally, we're going to have kind of a parabola connecting the end pieces and coming up and like so. So it's going to kind of look like this. Okay. And basically, it's going to be elongated along the y-axis, since y is the dominant variable here. Okay. And basically, and I'm keeping it condensed. So if you look at it, do kind of a freehand of what's going on here, essentially what you have is sort of this saddle, okay, that is being formed. Okay. Any questions? Okay. All right. So that is dealing with all the graphs. All right. Now, again, for the section with the equation of lines and planes in space, I will get those answers up again before the end of today. Okay. Any questions? All right. So let's continue on into section we were working in. Okay, so we were working on in the section dealing with vector functions and their derivatives. Okay. Did we get to the last two examples in that section? Because I think those are the last two we've got to finish, correct? Okay, so give me 1 second. Let me get everything situated. So I have enough room to write. Okay. All right, so our example. All right, so in this example, basically we're given the position vector in space of a particle. We want to find the angle between the basically the velocity vector and the acceleration vector. Okay, so we are at the time t. So we're told that the position vector rt is defined as 4/9 times 1 plus t to the 3/2 in the ith direction, plus 4/9 1 minus t to the 3/2 in the j direction, plus 1/3 t in the k direction, and t is equal to 0. Okay, so with this problem, please keep in mind that Doing the derivatives should not be the hard part of this, but just keep in mind that you do have to make sure that you do take the derivative correctly, because if you don't, then you're going to end up coming up with a different value than what is needed. Okay, so for the velocity vector, we should end up with, we're going to end up with 2/3 times 1 plus t to the 1/2 in the I direction. And then it's going to be minus, we're going to end up with 2/3 times 1 minus t to the 1/2 in the j direction, plus 1/3 in the k direction. And then for the acceleration vector, we're going to end up with 1/3 times 1 plus t raised to the negative 1/2 in the I direction. We're going to end up with plus 1/3 times 1 minus t to the negative 1/2 in the j direction, plus 0 in the k direction. Okay. Any questions there? Okay, so now that we have the derivatives, we need to find what the vectors are at time t equals 0. So v of 0, we're going to end up with 2/3 in the I direction minus 2/3 in the j direction plus 1/3 in the k direction. And then the acceleration vector at t equals 0 is going to give us 1/3 in the I direction plus 1/3 in the j direction plus 0 in the k direction. Any questions there? Okay, so we are looking for the angle between the two vectors, the velocity and acceleration vector. So we know that that formula is that theta is going to be the cosine inverse of the dot product of the two vectors divided by the magnitude of each of the vectors. Okay. So let's switch to a new page to finish up this problem. All right, so first, if we do the dot product of the two vectors, okay, and let's see here, that might work. All right, so if we do the dot product of the two vectors, so we're going to have 2/3 times 1/3, which is going to give us 2/9, plus, then we're going to have negative 2/3 and 1/3. That's going to give us a negative 2/9. And then finally, we're going to have 1/3 times 0, which is going to give us 0. So we know that the dot product is going to be 0. All right, so the magnitude of the velocity vector, okay, at 0, well, that's going to be the square root of 2/3 squared, which is 4/9, plus negative 2/3 squared, which is going to be 4/9, plus 1/3 squared, which is going to give us 1/9. So we're going to end up with a value of 1. And then for the magnitude of the acceleration vector, we're going to have the square root of 1/3 squared, which is 1/9, plus 1/3 squared again, which is going to be 1/9, and then plus 0, which is 0. So we're going to end up with the square root of 2/9. So again, we know that theta is going to be the cosine inverse of the dot product, which is 0, divided by the magnitude of the velocity vector is 1, times the magnitude of acceleration vector, which is square root of 2/9. So our angle measure is going to be what?
Pi over 2.
Say it again.
Pi over 2.
Okay, yeah, pi over 2. Okay. All right. Any questions there? Okay. All right, and let's look at our last example. Okay, so our last example here is just given the position vector in space, find the parametric equation for a line that is tangent to the given curve at the given parametric value t equals t sub 0. So in this example, we are told that the position vector, which is r of t, is equal to 2 times the sine of t in the I direction, plus 2 times the cosine of t in the j direction, plus 5t in the k direction. And we're told that t sub 0 is equal to 4 pi. Okay, so let's think about this. If we are writing an equation of a line tangent to writing an equation of a line tangent to a curve, what do we need to find? Yeah, we need to find the derivative. So essentially, since we know the first derivative of the position is going to be a velocity, we're going to find the velocity vector. So the velocity vector is going to be, in this case, 2 times the cosine of t in the I direction minus 2 times the sine of t in the j direction. Oops. Did I leave a component off? Okay, never mind. Plus 5 in the k direction. Okay. So essentially, what I want to do is evaluate this at pi over 4. So if I evaluate this as pi over 4, I'm going to end up with 2 in the I direction minus 0 in the j direction plus 5 in the k direction. Okay. Now, in order to write the equation of the parametric line, what else am I missing? So what is the other thing that I'm missing in order to write the parametric equation of a line?
The slope.
We found the slope. Yes, we're missing a point. Okay, we're missing a point. Well, how do you think we're going to find this point? So how can we find a point?
Put 4 pi in r of t.
Yes. So if we plug 4 pi into r of t, that will give us our point. So if we find r of 4 pi, we're going to end up with 0 in the I direction plus 2 in the j direction plus 20 pi in the k direction. Okay, so with that, we've got all the information we need in order to write our equation. Okay, so for our first equation for x, what would be our equation for x? Parametric equation for x.
2t.
Say it again.
2t.
Yes. What would be our parametric equation for y?
Just 2.
Just 2. And then what would be our parametric equation for z?
20 pi plus 5 t.
Yes, 20 pi plus 5t. Right. Any questions? Okay. All right. So any questions about vector functions and their derivatives? Okay. All right. So next, we're going to move into our next bit, which is going to be dealing with integrals of vector functions. Okay. So if you've got the notes for this in front of you, basically I'm just going to kind of read them off. All right. So starting off, the first one is the definition. It says the indefinite integral of r respect to t is the set of all antiderivatives of r denoted by the integral of r of t dt is equal to capital R of t plus c. Okay, so just your basic integration, and simply what it's doing, just like what we were doing with the derivatives, we had to take the derivative of each of the components. So when we do the integral, we integrate each of the components. Okay. A definition, it says if the component of r of t is equal to f of t in the I direction plus g of t in the j direction plus h of t in the k direction are integratable over a to b, then so is r. And the definite integral of r from a to b, so it would be the integral from a to b of r of t dt is equal to the integral from a to b of f of t dt in the I direction plus the integral from a to b of g of t dt in the j direction plus the integral from a to b of h of t dt in the k direction. Okay, so basically what this is doing is just showing you that you can also do the definite integral for these. Okay. Any questions? Okay, so the next piece that we have is dealing with the ideal projectile motion. Equation. So what this is that r is equal to b of 0 times the cosine of alpha times t in the I direction plus, then we're going to have v sub 0 sine of alpha times t minus 1/2 gt squared, and this is in the j direction. Okay, so what this is just basically if you remember, r represents your position function. Okay, and this is representing how the function is moving. Okay, so this component here, okay, is going to be dealing with your horizontal distance, whereas this portion here will be dealing with your vertical distance. Okay, so it's kind of giving you both pieces together. All right, v sub 0 just basically represents your initial velocity. Okay, so typically, if it's in terms of if we're doing English, it's going to be 32 feet per second. If we're doing metric, we use 9.8 meters per second. Okay. Alpha is going to be your angle. Okay. And basically, when you're thinking about alpha, okay, so if this is your horizontal and this is your projectile, so alpha is going to be the angle that is formed with the horizontal and this. So this is going to be alpha, that angle that's formed for the initial bit of the projectile. Okay. G is standing for the constant for gravity. Okay. All right. Any questions there? Okay. Now, out of this, if we know that we are dealing with the ideal projectile motion, okay, we can find out some things. Okay. And we have some formulas for this. All right. So the first one is dealing with the maximum height. Okay. So the way we find the maximum height is y max. It's going to be equal to the initial velocity times the sine of alpha. We're going to square that quantity, divide it by 2 times g. Okay. Next is dealing with the flight time. So t is equal to 2 times v sub 0, so the initial velocity, times the sine of the angle, alpha, divided by g. Then our final thing we're going to deal with is the range. So it's going to be r is equal to, we're going to take the initial velocity and square it, divide that by g, and then multiply by the sine of 2 alpha. And I'll show you how to use each of these, maybe not all of them, but show you how to use the formulas based on the situation we have here with the examples that I have. Okay. Any questions? All right, so let's take a look at some examples. Okay, so the first example is that we want to evaluate the integral. Okay, so for A, we've got the integral from 1 to 6 of 6 minus 6t in the ith direction plus 3 times the square root of t in the j direction plus 4 over t squared in the kth direction dt. So basically, in order for us to do this, we're going to use the second definition we talked about in this section. And what we're going to do is to integrate each of the pieces and then evaluate it based on the limits of integration, since it's a definite integral. Okay, so if we do that, for the first piece, if we integrate that, we're going to end up with 6t minus 3t squared. We're going to evaluate from 1 to 6, and it's going to be in the ith direction. Plus, for the antiderivative of the second piece, we're going to end up with 2t to the 3 halves we're going to evaluate it from 1 to 6, and we're going to deal with this in the j direction. Okay. And then for the last one, if we take the antiderivative of this, it's going to end up being minus 4 over t. Evaluate it from, again, 1 to 6, and this is going to be in the k direction. Any questions there? Now, in this course, I don't expect to see the calculations for the fundamental theorem, okay, of calculus. So the evaluation of definite interval. Just keep in mind that you want to make sure that you double check and make sure you don't get things incorrect. Okay. So if I take a look at this, all right, I'm going to have 36 minus, what's that going to give me? 108. And then I'm going to subtract 6 minus 3. So I'm going to end up with negative 75 in the ith direction. Okay. Any questions there? All right, so for the next piece, I'm going to have plus, I have 2 times. Now, here's the thing with this. If you cannot come up with a value, do not do a decimal approximation. Just leave it as an exact answer. So 6 to the 3 halves, I'm not going to be able to come up with an exact answer there. Okay. At least I don't think so. No. Okay. So I'm just going to leave it in as 6 to the 3 halves here. And then minus, if I do 1 to the 3 halves, I'm going to get 1. And I'm going to have it in the j direction. Okay. Then minus. All right. Now, if I put in the other piece, I'm basically going to have 4 6 minus 4, which is negative 10 thirds. So I'm going to end up with a positive 10 thirds in the k direction. And that would be my answer. Any questions? Okay. All right, so let's take a look at the second problem. So if I take a look at the second problem, I have the integral from 0 to 1 of 2 over the square root of 1 minus t squared in the ith direction, plus the square root of 3 over 1 plus t squared in the k direction, dt. Okay. All right, so basically what I'm going to do is just go through and integrate. All right, so if I integrate the first piece, what will I get? before we go too far in this, how are you guys doing this problem? Doing that first piece.
I think we have to use the trig integral.
You can, but let's not.
Okay.
All right, so real fast. Okay. Some integrals that you need to know, and basically because they fit a pattern. So if you've got the integral of du over the square root of a squared minus u squared, okay, this is always going to integrate to, and gotta be careful on this.
Inverse sine
So it's going to be sine inverse of, of u over a plus c. Okay, so that is always going to integrate that way. Okay. All right, and then the next one, if I have the integral of du over a squared plus u squared, okay, this is going to be 1 over a times the tangent inverse of u over a plus c. And then the last one, if you've got the integral of du over the absolute value of u times the square root of u squared minus a squared, it's going to be equal to 1 over a secant inverse of the absolute value of u over a plus c. Okay. I know, and I give you these for a reason, because if it falls into one of these three patterns, then you know it's going to integrate to an inverse trig. Do not use trig substitution unless it's warranted. Okay, so if you don't have to go through the whole process of trig substitution, you can have it fit one of these forms, you're ready to go. Okay. So now, with that in mind, let's go back. What would be the antiderivative of the first one?
two sine inverse t.
Right. So it's going to be 2 times the sine inverse of t, and we're going to evaluate from 0 to 1, and we're going to have plus. Now, for the second one, what would be the antiderivative?
Root 3. Oh, no. Sorry, wait.
So square root of 3 times what?
Tangent inverse
Right.
t
So tangent
over, yeah, t.
It's just t, and then we're going to evaluate from 0 to 1. Okay, and sorry about that. Got to put the components I and j. All right. So if we take a look at this, it's going to be 2 times. All right. So if you plug in 1, what's the sine inverse of 1?
Pi over 2.
Right. So we're going to have pi over 2 minus sine inverse of 0 is going to give you what?
0.
Right. Okay. And then again, keep in mind this is going to be the ith direction plus, then we're going to have the square root of 3 times. All right. So what's the tangent inverse of 1?
Pi over 4.
Right. Minus tangent inverse of 0.
0.
Right. And this is in the j direction. So we're just going to end up with pi in the ith direction plus square root of 3 pi over 4 in the j direction. Okay, and this is going to be our answer. Any questions? Okay, so at this time, it's almost noon. Let's do a 2-minute break, and when we come back, we'll finish up the material in this section. Okay. Okay, so I do have the answers now posted for the equation of lines and planes in space. So that now does have the answers available for you guys. Are there any questions? Okay, so next, let's look at our next example. The next example is asking us to solve the differential equation with the given initial conditions. Okay, so if we take a look at this particular problem, we have this, our differential equation is defined as dr dt is equal to 180t in the I direction plus 180t minus 16t squared in the j direction. Okay, and then our initial condition is that r of 0 is equal to 100 in the j direction. Okay, so the way this is going to work is that we're going to take the differential equation. All right, and what we're going to do is to integrate each side. Okay, so if we integrate the left, it becomes the equation r of t. Okay, if we integrate this first term, we're basically going to end up with 90t squared plus c in the I direction. Okay, and then for the next component, we're going to end up with plus, if we integrate this, we're going to have 90t squared minus 16 thirds t cubed plus c in the j direction. Now, one of the things I need you to understand is that these c's are not the same. Okay, so you could have some constant that is tied to the I component, one constant tied to the I component, and a different constant tied to the j component. Okay, any questions there? So now what we're going to do is to use the initial condition. So the initial condition says that when t is 0 is equal to 100 j. Okay, so in place of r of 0, we're going to put in 100 j equals, and we're going to put 0 in for t. So what we're going to have is c in the I direction plus c in the j direction when we plug in 0. Now, basically what we're going to do is just equate each side based on the components. Now, for the first c, for the ith component, do we have a value on the left-hand side? No. So what would the value of c be? It would be 0. Good. And then for the j component, okay, the value of c would be equal to what? It would be 100. Okay. So our equation, essentially what we're going to do, we're going to get rid of this c here, okay, because we said it was 0. And then this c down here gets replaced with 100. Okay, and I'll write this, and then we can write this whole thing out on the next page. Okay, so basically our position vector, okay, RT, is equal to 90t squared in the ith direction plus, then we're going to have 90t squared minus 16/3 t cubed plus 100 in the j direction. Any questions? All right. So next, what we're going to do is to deal with the second problem. Okay. So it's telling us that the differential equation is defined as d squared r dt squared, and that's equal to negative of 1 in the ith direction plus 1 in the j direction plus 1 in the k direction. Okay. We're given initial conditions. It says that r of 0 equals 10 in the ith direction plus 10 in the j direction plus 10 in the k direction. And we're told that dr dt evaluated at t equals 0 equals 0. Okay, so if we start, we're going to have d squared r dt squared is equal to. Now, for this, to make my life easier, what I'm going to do is just run the negative through. So I'm going to have negative 1 in the ith direction minus 1 in the j direction minus 1 in the k direction. So what I'm going to do first is to integrate each side. Now, if I integrate the left-hand side, it's just going to become dr dt equals, okay? If I take the antiderivative for the first term, what will I have?
Negative ti.
Okay, we need to do a little bit more than just negative t.
Let's see.
Yes,
Yeah.
so it's going to become negative t plus c in the ith direction, okay? Plus, if we take the antiderivative of the second term, it's going to be basically the same. So it's going to be negative t plus c in the j direction. And then the same thing is going to happen for the last term. It's going to be plus negative t plus c in the k direction. Okay. Any questions there? Okay, so let me go to a new page. So we said that dr dt is equal to negative t plus c in the ith direction plus negative t plus c in the j direction plus negative t plus c in the k direction. Okay, so what we're going to do is to use one of the parts of the initial value from the initial conditions. So we're going to use that dr dt evaluated at t equals 0 is equal to 0. Okay, so if we use that, all right, that means we're going to have that 0 is equal to, and we're going to plug in 0 for t. So we're going to have c in the I direction plus c in the j direction plus c in the k direction. So that means for all those c's, they are equal to what?
0.
0. Okay, so that means that dr dt is actually going to be negative t in the I direction minus t in the j direction minus t in the k direction. Okay. Any questions there? So now what we're going to do, because we want r, not dr dt, we just want r. So we're going to integrate again. Okay, so if we integrate the left-hand side, right, we're going to end up with r of t. Now, if we integrate this first term, what are we going to end up with?
Negative t squared over 2.
Keep going. Yes, don't forget the plus c.
Yeah,
So
plus c.
we're going to have negative 1/2 t squared plus c, and this is in the I direction. Well, we're going to get the same thing for the next term. And we're going to get the same thing for the last term. Okay? Any questions there? Okay, so we're going to finish up. So we know that r of t is equal to negative 1/2 t squared plus c in the I direction plus negative 1/2 t squared plus c in the j direction plus negative 1/2 t squared plus c in the k direction. So we're going to use the other initial condition that we were given, which was that r of 0 is equal to 10 in the I direction plus 10 in the j direction plus 10 in the k direction. Okay, so in place of r sub 0, we're going to put this expression in. And everywhere there's a t on the other side, we're going to put in 0. So we're going to end up with c in the I direction plus c in the j direction plus c in the k direction. Now, in the case of this, all the c's are going to be equal to what? And they're going to be all equal to 10. So our final answer for this, r of t, is going to be defined as negative 1/2 t squared plus 10 in the I direction plus negative 1/2 t squared plus 10 in the j direction plus negative 1/2 t squared plus 10 in the k direction. Any questions? So let's remember that in order for this to work, you must match up the components. So I component and I component match up. So the coefficient and coefficient must match up. Okay. And then the same way with the J's to J. So that means C is 10. CK, CK. So C is 10. Okay. Any other questions? Okay, so let's look at our next example. All right, next example we have is, it says find the muzzle speed of a gun whose maximum range is 24.5 kilometers. Okay, so if we take a look at this particular problem, all right, so what we're trying to do is to find the muzzle speed, okay? And what we are given is what the maximum range is. So what we're going to do is we're going to use the range formula in order to do this, okay, for the that falls under the ideal motion, okay? So for this, okay, R is equal to v sub 0 squared over g times the sine of 2 alpha, okay? Now, we're told, okay, in this problem, we're told what the maximum range is, all right? So we're going to put in 24.5 here, okay? So this is going to be equal to v sub 0 squared over g times the sine of, now, we need to figure out what the angle will be, okay? So what angle would allow us to be at the maximum that will give us a maximum of sine? So what angle will produce the maximum for sine? In this case, it would be 45 degrees, okay? Now, if it wasn't 2 alpha, if it was just alpha, it would have to be what?
90.
It has to be 90, okay? So essentially, it was 90 degrees that will give us the max for sine. But since it's 2 alpha, we just need to divide that in half. So that's where we get the 45 degrees from. Okay? Any questions there? Now, we know that the sine of 90 degrees is what?
1.
1. So this is going to give us 1. So what we're going to end up with is 2.5 is equal to v sub 0 squared over g. Okay? All right, so what we're going to have is 2.5, and keep in mind it's 2.5 kilometers, and that's equal to v sub 0 squared divided by. Now, for gravity, we are going to use the metric, so we're going to use 9.8, okay? And it's going to be 9.8 meter per second squared, okay? Now, before we can solve this, we need to do something. Yeah, convert the range to meters, correct. So we need to multiply this by 1,000 to convert it to meters. Okay, so if we do that, we're going to have we're going to have 24,500 is equal to v sub 0 squared over 9.8. So essentially what we're going to do is to multiply both sides by 9.8. So we're going to end up with 240,100. That's equal to v sub 0 squared. And to solve for v sub 0, we're going to take the square root of both sides. So what would v sub 0 be? Yes, 490. And what will my units be?
Meter per second.
Yes, meters per second. Okay. Any questions there? Okay. All right, so let's look at our next example. All right, so in this example, it says a baseball is thrown from a stand 32 feet above the field at an angle of 30 degrees up from the horizontal. When and how far away will the ball strike the ground if the initial speed is 32 feet per second? Okay. If you are dealing with that, yes, it will be, because of the fact that we need to make sure that the angle will be produce the maximum value, and you just have to think about it in terms of the unit circle. So the maximum value that sine can be is 1, and the value of sine is going to be is 1, and that occurs at 90 degrees. And since it was 2 alpha, alpha has to be 45 degrees. Okay. Any other questions? Okay, so for the next example, so let's look at this. All right, so in this example, we know we're in the stands. Oops, turn my pencil back on. We're in the stands. Okay, and basically what's happening is that the ball is being thrown, and we want to know when and how far away will the ball strike the ground. Okay, so if we take a look at this, all right, we're going to be looking for this distance. Okay, but there's a couple other things that we need to take into factor. Okay, now since we are dealing with this distance, okay, we're dealing with two distances. So we're dealing with a distance up and a distance across. So a distance across, we're going to let that be represented by what variable? So this distance will be represented by what variable?
R.
Not R. So let's just think about in terms of our coordinate system. So either X or Y.
X.
Okay, it will be represented by X. And then this distance here will be represented by what?
Y.
Y. Okay. All right, so let's first start off with the Y. Okay, so the Y, we know, okay, we've got an initial Y, and then we've got what's happening. So we've got an initial velocity times the sine of alpha times t minus 1/2 g t squared. Okay. Now, we don't necessarily know how high up it goes. Okay. But, okay, we do know y sub 0. So y sub 0 is going to represent the initial height. So what is the initial height? It's going to be 32 feet because remember we're 32 feet up. Okay. Plus, all right. Now, in this problem, they tell us the initial speed. What is the initial speed? It's 32 feet per second. So in place of v sub 0, we're going to put in 32. Give us a sign of alpha. Did they tell us what the angle is? It's 30 degrees. Should be 30. So it's 30 degrees. All right, t represents time. Are we given any time? No. So we're going to be looking for that. And let me not put equals there, put a minus. 1/2, okay. G, which is gravity, is going to be 32. And then we're going to have t squared. Okay. Now, let's think about this. Essentially, what
I
do we
think the
want
gravity
y
is
to be?
9.8. I'm sorry.
Say again?
I mean, the G is 9.8, right?
No, it's because we're working in feet. So it's 32 feet per second.
Oh, okay.
Okay. All right. So in this problem for y, what y value are we essentially looking for?
0.
We're trying to find out when y is 0. We're trying to find out when it hits the ground. Well, when it hits the ground, that's when the height is 0. So we're going to set this equal to 0. Okay. So essentially what we're going to do is we're going to solve this equation for t. Okay. So let's take a look at this. So we have that 0 is equal to 32 plus 32 times the sine of 30 degrees times t minus 1/2 times 32 times t squared. So we're going to have 32 plus, well, what's the sine of 30 degrees? What's the sine of 30 degrees?
1/2.
1/2. So we're going to take half of 32, which is going to give us 16t, minus, this is going to give me 16t squared. Okay, and keep in mind this is equal to 0. So we're going to solve for t. In this problem, I'm going to make my life easier. I'm going to divide everything by -16. And the why I want to do -16 is because I really want the coefficient on t squared to be positive. Okay, so if I divide everything by -16, I'm going to end up with t squared minus t minus 2 is equal to 0. Now, it factors nicely, and always keep in mind that if you don't see how to factor it, if it's quadratic, you always going to use what? So if you can't see how to factor and it's a quadratic, you should use what? Yes, the quadratic formula. Okay, so never forget about that quadratic formula. It's your lifesaver, especially when you're dealing with quadratics. Now, as I said, this factors nicely into t minus 2 times t plus 1 equal to 0. So we're going to get t is 2, and we're going to get t is -1. Now, does both of those times make sense?
No.
No. Which one doesn't?
-1.
Right. So we need to get rid of that. Okay. So if you look at the question, we've answered the when part, when the ball will strike the ground. So it's going to take 2 what?
2 seconds.
It's going to take 2 seconds before to hit the ground. All right. So we found that portion. So next, we want to find how far. Okay. So on the how far, oops, too far. We are now going to be focusing on this horizontal distance. Okay. So with the horizontal distance, in this case, we're going to say that x is equal to, there's some initial x value plus, then we're going to do v sub 0 times the cosine of alpha times t. Okay, so we're going to end up with x is equal to, now, as far as x is concerned, if we look at our picture, x of 0, when it starts, we would say that that's going to be what? So what's going to be the horizontal distance? It's going to be 0, okay? So this is going to be 0 plus, we were told that the initial velocity was 32 feet per second. Then we got the cosine of the angle that it was launched at was 30 degrees. And we just found t, which was 2 seconds. Okay, so if we multiply this together, so we're going to end up with 32 times cosine of 30 degrees is going to be the square root of 3 over 2. Okay, then we're going to multiply this by 2. So we're going to end up with 32 times the square root of 3. Okay, and we're going to do an approximation here because 32 square root of 3 doesn't, as a distance, doesn't make sense. Okay, so we are going to do a decimal approximation here. So if we do a decimal approximation, we're going to end up with about 55.4 feet. Any questions? Okay. All right, so I only have 6 minutes left, and I don't want to rush through that last example to try to get it done in the last 6 minutes. So we're just going to hold off for that to be completed on Tuesday. Okay, so you need to, as I stated earlier, after the break, I've got the solutions posted for the homework over lines and planes in space, so that those solutions are posted. I don't think I have the solutions posted for the derivative homework, vector functions and derivative. I don't have the solutions posted for that, so I'll work on getting those solutions posted also. That is the homework assignment that you need to be working on. So vector functions and their derivatives is the homework assignment that you need to be working on for Tuesday. Okay. Also, quiz 3 is now open and it is due on Tuesday. Okay. Any questions? All right. Well, that is it for today. You guys have a great rest of your day. Have a great weekend. And I